Hey everyone, welcome back to the channel Crash Code. Today we will be solving a problem from the Leetcode named as maximum depth of a binary tree. So in this we are given a root of the binary tree. This is the root of a binary tree, and what we have to return is its maximum depth. So if the root of a tree is given, we have to return the maximum depth of that tree. So we have to find the maximum depth of a binary tree. Let's assume this is the binary tree for which we have to find the maximum depth. So let's understand what is the maximum depth. The maximum depth is the number of nodes along the longest path from the root node to the furthest leaf nodes. So here the farthest leaf nodes are these from the root node, as the root node is this one. So the number of nodes between these between this path is 1, 2 and 3, or the another similar path is 1, 2 and 3. So here the answer is 3. So let's write one pseudocode for this problem. We will be calling a recursive function, let's say an arbitrary function which will be taking a node variable as an argument and calling itself recursively again and again. So this is a function. Let's create one base case for this. If root equal none, it should return 0. Okay, so here the recursion will stop. What we are aiming is, when this function is called for any node, so that node should return the height of the tree or the number of nodes below it, the longest path within the longest path. So if we are calling this node, so it should return first counting itself, that is +1 for itself, and then adding it to the longest path below it from either left side or right side, whichever is the longest. So from the left it will be returning 1. So 1 plus 1, this whole 3 node will return 2 from this function. And for the right one, if the right one is the longest, so right one will be returning 1, 2, 2 and 2 plus 1 for itself. So for the right one, if it will consider, so it should return 3. So from 3 and 2, the longest one is 3, so this whole node will be returning 3 from this recursive function. Similarly, all the nodes will be returning the value according to this recursion only. Let's consider again this node. So this node will be returning the value as 1 plus 1 or 1 plus 1, which will be the maximum. In this case both are equal, so it will be obviously returning 2. So as I said earlier, this node will be returning 2 to this 3 node, and 2 plus 1 will give 3 for the whole tree. So let's create one variable int l, which will call recursive function for the left part, root.left. Another variable which will be calling for the right path. Okay, now one more variable int max, which will find out the maximum among the two, which one is the longest, which one node from the left or right. For this one, for the left and right, which one is giving the longest possible path. Finally, this will return 1 plus max. Why 1 plus max? Maximum or the max for the path for the maximum nodes below it, and 1, it will be count the node which is being passed will also count itself before returning. So this is the pseudocode for the recursive solution for maximum depth of binary tree. So let's move on to the Java solution. So this is the problem statement, and we have to write the Java solution for finding the maximum depth of this tree. So these are some test cases given to us. So let's start. First of all, as I said, this is a recursive function. So we have to create one base case for recursion to stop. So the base case will be, if the root node given to us is none, then this function should return 0. As simple as that. Now we will be creating two variables, left and right, who will be containing the value of the height or the number of nodes below, including that node. So left node variable will returning the number of nodes including itself below it, and the right node similarly will be returning through the right one. Now we will be directly returning the value which will be maximum of right node or the left node with one increase to it. So we will be writing 1 plus math.max either left node or right node. So this function will be returning one increased value with the maximum of either left or right node. So let's test it first. As you can see, it passed the test case. Now we will be submitting the solutions. Yes, it perfectly worked. Thank you for watching this video. Please subscribe and like the video if you liked it.